So today's lesson is going to involve scatter plots. Now, scatter plots are always comparing two different types of data and representing that data on a graph. And since it's two different types of data that you're comparing, all scatter plots are going to use bivariate data. Now, there are three types of trends or correlations that scatter plots use to identify what's happening. So there's either a positive correlation, a negative correlation, or no correlation. And as you can see from the first graph, when they're comparing homework grades to test scores, as the homework grades increase, so do the test scores. So this is going to be what we consider a positive correlation. Correlation meaning relationship between two things. And in all cases of a positive correlation, as the x increases, so does the y. In the next graph, as we compare the amount of hours that you sleep each night versus the overweight in pounds, meaning how much you are overweight, you'll see that as the number of hours of sleep increase, the amount of weight that is overweight considered will decrease. So this is called a negative correlation. And as we can see from the graph, as the x increases, the y will decrease. Now in our final graph, we have the number of hair washings per week versus the number of bald people, and clearly these dots are just scattered, it looks random, and therefore there is no correlation. There's no relationship between the amount of times you wash your hair per week and the amount of bald people. And therefore x and y are not related. And so these are the three types of scatter plots that you'll see. You have to be able to recognize if, in fact, the scatter plot is positive, negative, or no correlation just by looking at how the dots are arranged. Now, the next example, we're given a graph that compares the shoe length in centimeters to the reading level, and it asks to describe the relationship between the data. So what we can say is that as x increases, right, as we go left to right, and we read the graph, the y values are also increasing. Now, part B says, does x cause y to happen? So it's asking, does your shoe length cause your reading level to change? Now, obviously no. Okay, people with smaller shoe sizes aren't necessarily at a lower reading level than people with bigger shoe sizes. The reason that we're seeing this trend is because typically, as people get older and their shoe size increases, their reading level also increases, but it's not causing one thing to happen over the other. For part C, where it says to describe the correlation, it's asking, is it positive, negative, or no correlation? And this would clearly be a positive correlation because as x increases, so does y. The next part says the line of best fit describes the trend of data and sometimes referred to as the regression equation. So there are two types that we're going to focus on dealing with this. One is linear extrapolation. Now if you think of extra, try to remember extra like outside, and it's when you use the line of best fit, which is the linear equation, like y equals mx plus b, straight line, to predict values that are outside the range of given data. Now, as an example to show what I mean by this, when you have a line of best fit, you have this straight line that goes through some points in your scatter plot, and you use this line to predict either information that is within your range of data or outside of your range of data. So, for instance, if I had this straight line, right, and let's say that this was my line of best fit to predict future things, then if I focus on something that is perhaps outside of the given range of data, right, like up here, then I'm going to use this line of best fit to calculate what that might be. Now, for linear interpolation, think inter, inside, kind of correlates. This is the opposite. This is when you use the line of best fit to predict values that are inside the range of data. So again, the big difference here is extra is the outside part. So when you're looking at your data, any number that doesn't quite fit in between your lower and upper extremes would be in the outside range. Linear interpolation is when you're predicting things that are inside the range of data. So where you would look at your line of best fit and you would focus on points that are inside the range of data. So somewhere in between your lowest and highest values. On to the next part of your notes. In example 2, it says, given the data, construct a scatter plot for the number of passengers and bus mileage. Label the dependent variable or the dependent data as y and the independent data as x. So the number of passengers is going to be our x, and the number of miles per gallon is going to be our y. So we're going to label our x and y axis with those words first. And then we're going to go ahead and plot these different points. So your first point, number of passengers is 1, and the number of miles per gallon is 31. So we've got when x is 1, y is 31, we're going to try to just plot a point there. When x is 2, the number of passengers is 2, your y value is 30. At 4 passengers, the miles per gallon is 27. At 6 passengers, the miles per gallon is 18. And again, these aren't going to be perfectly accurate, but do your best. At 8 passengers, the miles per gallon is at 10. And at 10 passengers, the miles per gallon is 6. Do not connect these dots, not yet. Okay, so there's our graph. Then we have a few questions to answer. Is this data univariate or bivariate? Remember, it can never be both. It's either one or the other. And so you need to circle which one it is. And in the beginning of these notes, I said that all scatter plots are bivariate because you're comparing two different types of data. In this scenario, we're comparing the number of passengers to the number of miles per gallon. Then in part B, we're going to draw the line of best fit and describe the trend of data that follows. So what you're going to do is you're going to just do your best to draw a line, and looking ahead at part E, I would use the point 230, so the point 230 and the point 618, and I would, if I had a ruler and I could use it on here, I would connect those points with a ruler and draw a straight line. And that's the best I can do. Notice that my line of best fit doesn't have arrows. This is just to set it apart from a typical line. So your line of best fit is just a straight line, but it doesn't have any arrows. And then it says, is X causing Y? So do the number of passengers cause the number of miles per gallon to decrease like our trend is showing? And we are going to say yes. And this is called causation. When one thing causes another thing to happen, in math we call it causation. And causation is a new vocabulary word, but luckily it sounds like cause, so that should be helpful in remembering what that means. Part D says, is there a correlation? If so, is it positive or negative? Clearly, this is a negative correlation because as the number of passengers increases, the number of miles per gallon decreases. So this is a negative correlation. Okay, on to part E. We're going to now write the equation for the line of best fit using 2 points on our graph, and this is why I told you to try to make your line of best fit going through those 2 points specifically. Now, in order to do this, if we're coming up with a line, right, and remember, think back, it's been a while, but your line comes from y equals mx plus b, we need to figure out 2 things. We need to figure out m, which hopefully remember is slope, and we also have to figure out our b value, which hopefully remember is the y-intercept. Now, before we find the y-intercept, we have to figure out the slope. And the slope formula, which again I'm hoping you remember, is m equals the change in y, so y2 minus y1, divided by the change in x's, x2 minus x1. And from this point 230 and 618, we know that 18 and 30 are my y's, and 6 and 2 are my x's. So I'm going to start with my y's in the top, 18 minus 30, divide that by my x's, 6 minus 2. Now that will simplify to negative 12 divided by 4, and so I end up with a slope of negative 3. So I'm almost done. I have my slope, but I don't have my y-intercept. Now, there are 2 ways to find the y-intercept. The first, and typically the one that most kids choose, is using the formula y equals mx plus b, where I simply substitute in the slope that I have for m, so the slope is negative 3, and everything else that I have to offer, so I have a y value, and I'm going to choose between using either 230 or 618. I'm just going to use the first point I see here, which is 30, as my y, so 30 is my y, and my x here is 2, so that needs to replace where x is. The only thing I don't know is the y-intercept b, and now it turns into an equation that I can solve for the variable b. So to solve here, I'm going to multiply negative 3 and 2 together to get negative 6. Just be careful here because 6 and b look very similar, so don't get too confused. And then you are going to want to add 6 to the other side to isolate your variable b, and you're going to end up with 36 equals the y-intercept b. Putting that all together, you're going to end up with an equation y equals your slope, negative 3x, plus your y-intercept, 36, and there's the equation of the line of best fit. Now, just in case you don't like doing it this way, there is another formula that I will just write down for you, because I know some kids liked this formula when we did it before. Called the point slope formula. It's y minus y1 equals m times x minus x1. And when you use this formula, you replace the y1 with either y value of the point that you're given. You replace x1 with that point that you choose to use, and you also replace m with, in this case, negative 3. And then you would simply solve and get y alone, and by doing that, you are going to end up with the same answer. So again, you can use the y equals mx plus b, or the point slope formula, y minus y1 equals m times x minus x1. No matter what you decide to use, you're going to end up with, in this scenario, y equals negative 3x plus 36. Okay, in the next part, use the equation that we just found of the line of best fit to interpolate. Now, if you remember, interpolate means that it's within the range of data that we have to predict the gas mileage for 3 passengers. And if we look back at our graph, 3 passengers is x. So 3 should be somewhere around there. Now, just guesstimating, right, I'm going to say that it's probably, 28 maybe. So this is just me guessing based on the line that I drew. But to get a more accurate reading, we are going to use the equation to figure it out. So in order to use this equation, what we're going to do is we're going to replace the x in the equation with 3. So we have negative 3 times 3 plus 36. And when we figure out the math here, we're going to end up with 27 is our answer, which I guess is pretty close. So this is 27 is the y, and that represents miles per gallon. Make sure you give units when you can so that it makes more sense and brings it kind of full circle. Okay, part G. Part G says extrapolate to predict the gas mileage for 12 passengers. So 12 is going to be the x value that we're focusing on. If we look back at our graph, 12 is going to be off the grid. And since 12 is not in our range of data, this is why it is called extrapolating. So to predict this, we are going to use our equation that we found, but instead of x, we are going to replace x with 12. And when we do the math here, we are going to end up with 0 miles per gallon. And if we look at our graph to see if this makes somewhat sense, I guess I could see it. I don't know. My graph is kind of off, but it's not totally ludicrous to think that by plugging 12 into this formula, we get 0 miles per gallon. And that's going to conclude our notes today on scatter plots.